Hi students, hi friends. So this is the second part of CBSE Class 8 subject science, and the chapter was metals and non-metals. So we are discussing the next part of it. So in the first chapter, we studied what are the metals, what are the non-metals, how many are the metals, what kind of materials we call a non-metal, and we discuss certain properties through which we identify and we classify the material as metal or it's non-metal. Okay, just a quick recap of that was like we discussed different properties like malleability, tensibility, okay, sonorous property, and so on. Okay, now in this part we'll discuss the chemical behavior. Okay, chemical behavior of of the metal. So if we take a metal and we do some chemical event, like suppose we put that metal in air, or we put that metal in acid, or we put that metal in water, what will happen? Okay, so those kind of chemical activity we'll discuss in this, and in this part we'll just cover chemical behavior of the metal, and the next part of this video will discuss the chemical behavior of non-metals. Okay, so okay, so while discussing the chemical behavior, we'll discuss four kind of phenomena. First is air. What will happen when we keep the metal in open air? Okay, what will happen when one metal is displaced by another metal? What are the chemical activities in that? And what, and the two more will be the displacement of hydrogen. Okay, displacement of hydrogen from water, and in fourth we'll discuss displacement of hydrogen from acid. Okay, how many acids sulfuric acid, okay, HCl, hydrochloric acid, and so on. So we'll discuss those things in this now. So before that, actually, we need to know that the chemical activeness or the factor through which the metal acts with some other element is different. Not all metals are equal in behaving chemically with other metals or other substances, gases, and acids and all. So it depends on this bar actually. Let me give the focus of that here so that it will be more clear to you. I think it is now more visible to you. Okay. So if you see, this is the highest active metal, that is potassium. Okay, then the second active is calcium, then sodium, magnesium, aluminum, zinc, iron, hydrogen, copper, okay, mercury, okay, and silver and gold. So gold is a very inactive metal which does not in chemically interact with other things very easily. Okay, so very low activity is generated by the gold, but the most active one is potassium. So I will recommend you to remember this 10, or like I think it's 11 elements. So in this order only. So this order of activity is called activity series. Okay, so this is the activity series through which you can know that okay, iron is more active than copper. Okay, sodium is more active than aluminum, than zinc. Okay, so if you see the sodium, if you keep this sodium metal, that is very soft metal actually. Okay, if you keep this sodium in a in a usual air, or you can say the in common in atmosphere, then it catches the burn, it catches the fire actually. Okay, so you cannot keep the sodium and also the potassium in open air. You have to keep them in some kind of liquid through which it cannot expose itself into the air. So that liquid can be kerosene. Okay, so you put the kerosene and potassium into the kerosene liquid, then only it can be stored. Otherwise, if you keep it open air, then it will catch the fire and it will be wasted out. Okay, so this is the activity series. Okay, that is very important, and I will recommend you to remember this order. So, because with this simple list only, we'll discuss all this chemical behavior. Okay, okay. So, so let us discuss few things. We'll discuss 4 points. First, what will happen when we take the metal into the air? Okay, so in atmosphere, we have oxygen content in it, right? What we breathe is oxygen, O2. So in air we have ample amount of oxygen gas there. So what happens is, like, when we keep some metal into the oxygen, it turns into the metal's oxide. The first example I have given was the sodium. If you keep the sodium in air, then it will catch the fire and it will decompose itself. Okay, so that was the first activity. But other metals are not so active. If you see, this is suppose if you take the magnesium, aluminum, zinc. So these are not so active that can catch the fire or something like that. Those are less active than sodium and potassium. But if they are less active, but they are not inactive. Okay, so if you want to if you keep the magnesium in air, okay, in air it interacts with O2, but you have to like you have to give the stream of hot air, okay, so that magnesium strip can be reacted with air, oxygen basically. Then it will create its oxide, magnesium oxide. Got it? So magnesium will interact with oxygen and it will create its magnesium oxide. So if you want to balance out this equation, then on the left side and right side, the element count should be equal. Like right now, oxygen is 2 here, but oxygen is 1 only. So you will give 2 here. So now this 2 is kind of common to both. So now magnesium is also 2 and oxygen also 2. So oxygen is balanced out, but if you see, the magnesium is now 2, but magnesium here is 1. So what will you do? You will keep 2 here. Now magnesium is also 2 here and here. Oxygen is also 2 here and 2 here. Okay. So this is balanced equation now. You know, the balancing the equation kind of thing. So I will let you know while discussing this topic here. So magnesium is interacted with oxygen and it has created magnesium oxide. Okay, so this is the behavior of that. The other thing is, like, if you keep the iron, okay, if you keep the iron in kind of air which is having some water content, so humidity kind of thing is there. So if air contains some kind of moisture in it, then what will happen? The iron and those things create some kind of brownish material above it. Okay, we call it rusting. If you keep the iron metal in open air which has some moisture, okay, then if you see there is some rusting happens on the surface of iron. हिंदी में जैसे बोलते हैं जंग लग गया, right? तो क्या हुआ? Then in that case what happened is, like, iron interacted with the what happened? Iron interacted with the moisture and it created iron oxide. That is that actually what it does is, like, it decays the metal. The metal's life is getting reduced in that case. So it happens. So that is that event when the chemical action happens in the air with the metal is what it's called. It is called corrosion. It is called And rusting is example of that corrosion. That is very common. That if you see, if you keep your bicycle open in your house and rain comes on that bicycle, or some if you keep that bicycle open in kind of water or those kind of environment, then your bicycle gets started rusting. And if you keep that thing open for so long, like 4 5 years, then you will see that all the metal parts are destroyed in the rusting. Its life is reduced. Okay, so the rusting is one kind of what I call it, corrosion. Okay, corrosion. Okay, now the second thing is displacement of one metal by another. Okay, so suppose you have copper sulfate. Okay, and if you see this activity series, then copper is less active than iron. Okay, so you can do one practical also. If you have some test tube, then you keep the copper sulfate liquid in it. Okay, and put a nail of iron. There is a nail. Okay, you when you keep that nail into this liquid for some time, then what will happen? Copper sulfate is there, and you are reacting iron with it, right? And if you see the activity chart here, copper is less active and iron is more active. So what will happen? Iron will replace, uh, and it will make FeSO4. So this copper sulfate has now became iron sulfate. Copper is replaced by iron here, and the copper is separated out. So after some time, when you put this iron nail into copper sulfate liquid, what will happen? After some time, in this, so this nail, what will happen? This nail will have some copper stored on just this solution. So this is you have separated out copper from the sulfate. Okay, so you will see this copper is separated out, and this now the remaining liquid is nothing but iron sulfate, ferric sulfate you can call it. Okay, so this is how you have replaced copper with iron. Copper sulfate is now became iron sulfate, and the copper is separated out. So though that copper will be seen here, you will see the particles of copper here in brown color, and the solution will change. Earlier the copper sulfate solution was there. That copper sulfate solution is blue in nature, but this is having different color. Okay, so what we have done is we have displaced one metal, okay, from one compound with another metal. So copper sulfate, copper is replaced by iron here. Okay, now we'll see displacement of hydrogen from water and displacement of hydrogen from acid. Okay, so so take one example, like if you take the sodium, okay, and you put the sodium into water, what will happen? Okay, in this case, hydrogen will be separated out and sodium hydroxide will remain. Okay, so what you have done, you have separated out hydrogen. You have displaced hydrogen from water. What is the formula of water? H2O. That has two molecules of hydrogen and one of oxygen. So you have replaced H hydrogen from H2O to Na. So what will happen? It will become sodium hydroxide, and the hydrogen will be separated out. If you want to balance this equation, then if you see sodium is 1 here, sodium is 1 here, that is okay. Hydrogen is 2, hydrogen is 2 here. O is 1, O is 1. So that is already balanced equation. Nothing is required there. Got it? No, I made one mistake. Hydrogen is 2 here and 1. Hydrogen is 3 here, but here hydrogen is 2. Okay. So what will we do? We will take it as 2. Now hydrogen is 2 and 2, 4. Okay. Now hydrogen is 2. Okay. We'll have to make it 2H2. Now hydrogen is 2 to 4. Hydrogen is 2 to 4. Hydrogen is balanced. Oxygen is 2 and oxygen is 2 here also. So oxygen is also balanced. Now sodium is 1 here, sodium is 2 here. So we have to keep 2 here. So it is now balanced. Okay. Sodium is 2 and sodium is 2. Hydrogen is 2, 2s are 4 here. Hydrogen is 2 plus 2, 2 to 4. And oxygen is 2, oxygen is 2. Okay, so now you got that. Okay, so we have replaced hydrogen from water, and we have created a hydrogen separated and sodium oxide. Okay, so the last thing I want to show you is displacement of hydrogen from acid. Okay, so take the example of HCl. HCl is hydrochloric acid. So if you, it is liquid form. Okay, HCl is liquid form. If you remember, we have a lot of hydrochloric acid in our stomach also. That is content of our body. Okay, so when you take the sodium into the liquid of hydrochloric acid, then hydrogen will be replaced by sodium. That is Na, sodium. Okay, so now it will become NaCl. Okay, NaCl and H2 will be separated. So if you want to balance this equation, then hydrogen is 2 here, so we have to keep 2 here. Now hydrogen is balanced. Now Cl is 2, chlorine is 2, so we have to keep 2 here, so that chlorine is now 2. Okay. Now chlorine is 2, hydrogen is balanced. Now sodium is now 2 here. So in left side, what will we do? We'll keep 2 here. So now balance is balanced. Equation is balanced now. Okay, the same thing happens with magnesium, and I'm having less space here. So if you put, instead of sodium, you keep magnesium here, and you put that magnesium into sulfuric acid. What is the formula of sulfuric acid? H2SO4. Okay, so magnesium will replace hydrogen in H2SO4, and it will create magnesium sulfate, and the hydrogen will be separated out. So if I put Mg and sulfuric acid is H2SO4, then what will it create? It will create MgSO4, and hydrogen will be separated out. You can balance it out by yourself. Okay. So that is fine. And the last one, you can put iron, Fe, okay, into sulfuric acid, H2SO4. Then what will it create? It will create sulfuric acid. It will displace H hydrogen from sulfuric acid, and it will create FeSO4. Okay, ferric sulfate, and hydrogen will be separated out. So this was the chemical behavior of metals in different scenario. One was in air, one was in displacing one metal by another. So higher active metal will replace lower active metal. Okay, like copper sulfate plus iron. So copper will be replaced because it is less active, and it will create ferrous sulfate and copper. Displacement of hydrogen from water, displacement of hydrogen from acid. So this is how we have, and the last thing was reaction with bases. Okay, so if you take the only some metals like aluminum and zinc dissolve in alkalis. Not all metal get dissolved in alkalis. Alkalis means base. Okay, so only some metals like aluminum and zinc. Okay, aluminum and zinc, these two can be dissolved in alkaline solutions. Like aluminum plus potassium hydroxide will become potassium aluminate and hydrogen. Okay, so this was all thing, but the one example I gave was displacing hydrogen from acid. It's this one. So if you want to take one experiment in lab with your teacher, then you can experiment this. You can take iron nail. Okay, you can in a test tube. You can take one iron nail in you can dip that iron nail into sulfuric acid. You can there is a sulfuric acid. So what will happen? Like it will become iron sulfate. Okay, and hydrogen will be separated out. So if you will see, the nail will be disappeared after some time, and the white solution will appear. Got it? Okay, so this was all, and next part we'll see the chemical behavior of non-metals. Okay, so there will be different scenarios altogether similar with this. Like we'll see what will be the action of non-metals in the air, action in the water, and displacement of one non-metal by another from a salt. Okay, and in next topic only we'll see the uses of metals and non-metals, and we'll complete this chapter. Okay, so thank you students, and keep watching and liking, disliking as per your choice, and keep coming to our channel. Thank you.